Alright, hello. So this lesson is on what we're going to need to know for family of functions, a lot of the basics. Half of it will be review and half of it will be something new. And the objective is that I can determine if a relation is a function. So let's start off with the review. Domain and range. Domain is simply the set of x values in a relation, and range is the set of y values in a relation. Remember, we've always talked about this as ABC order. In the alphabet, domain comes before range, and x comes before y. So domain is the x and range is your y. Here's an example. Find the domain and range. Very simply, domain, we said, is the x, and range is the y. So domain, remember your squiggly brackets, and then you're just going to list your values in numerical order. 3, 5, 6, 10, 13, and 27. And then our range, these are a little harder to list in numerical order because they're not already there. So the smallest one is -8, and -5, 1, 6, and we don't list the duplicates. 6 is there, so I don't need to list it again. And then 7. That would be the domain and range when you're giving a table. Here's another example. This one's of a graph. Find the domain and range. This is our x-axis, so our domain is going to be which x values do we use. If I go to the furthest left point on my graph, I find it to be at -9. And then the furthest right, or the largest x value, happens to be +9. Then we do the same thing with our range. So range are my y values. So I'm going to be looking at my y-axis. The lowest or smallest y value, you see here, to be -5. And the highest and largest would be here at 8. Now this is how we've written domain and range in the past. Now that we have an understanding of inequalities, let's write it properly with an inequality. So bring my domain down here, and what this has meant until now was our domain is between -9 and 9, or all the values in between. So now I can write that as an inequality with the squiggly brackets. My lowest is -9 less than x less than 9 in your squiggle brackets. Remember, this says x is between -9 and 9. You just have to ask yourself, is -9 included and is 9 included? Well, when I look at my graph, I see I have this dot and it's closed, so that means it's included, so I need the equal to sign. And on the other side, I have a dot and it's also included at 9, so an equal to sign. We're going to do the same thing with range. I'm going to come down here and my range, write this with an inequality, because it's all the values from -5 to 8. So my lowest is -5 less than, range is in x, range are my y values, y less than my upper 8, and your squiggle bracket again. Ask yourself the same question. Do I actually get to -5? Well, I can see here the lowest point happens to be on an endpoint where the dot is. Because it's closed, I need the equal to sign. I'm going to go to the highest y value, over here at the 8. I see that I do indeed touch the 8, so it's going to have an equal to sign as well. Generally speaking, it'll be very obvious if there's not, because there'll be an open dot, very visible open dot that you see. There's a few other occasions, but we'll talk about those as it comes up. The newest thing, or the main thing here with the domain and range, is we need to start writing these in inequality form. Our new definition today is a function. So a function is a relationship between input or domain values and the output, the range. And in a function, the output depends on the input. There is exactly one output for each input. In other words, every value in the domain goes to exactly and only one value in the range. What does that mean, though? Determine if the following is an example of a function. If not, explain why. Remember, a function, every domain goes to exactly one range. So my domain is x. So I'm going to look at all my domains here, my x values, and say, are there any repeated values? That's the key way to look at this. Well, I have 3, 5, 12, 17, and 20. None of those values are repeated, which means I can already say right now that yes, it's a function. Because 3 only goes to the 9, 5 only matches with the 15, 12 with the 36, 17 with 51, and 20 with the 60. Let's look here now. Here's another table. In this table, I see that -7 goes with 15. 3 goes to 0. 8 goes to -7. -4 matches with 11. 0 matches with 8. And then I come back here to this -4 and 11. I already know I used -4 in my domain, so I'm going to come right over here to -4. Now this one in the table, the second one, says it goes to 11. And in my original set here, it also says it goes to 11. So even though -4 is repeated, it's being repeated and still matched with 11. So this would still be a function. This is a different way to represent a function. And these are like concept maps. Okay? Usually we label these input and output, and not so much domain and range. So I look at my input, here I have a 1, and he's matched to the -2. So far we're good. 3 goes with the 10, -5 matches with 4, and -7 is with my 11. None of those values repeat, and they're only matched to one thing. So yes, this would be a function. Here's this one though. So in this mapping, 1 is matched with -2. Alright, that's fine. 3 is matched with 10. That's totally fine too. -5 is matched with 4 and 3. So now I have one domain value, -5, but he's being matched to 2 different values. So already I know it's not a function. And I know it's not a function, again, because -5 is going to 4 and 3. You only want it to match to one number. Earlier we looked at the -4 matching with 11, but it always went to the 11. This -5 doesn't go to the same value each time. Therefore, it's not a function. Now, if you have a graph, it's a little bit more difficult to look at it number by number on the domain or your inputs. We have another way to test it, and it's called the vertical line test. A relation is a function if at no point a vertical line crosses the relation in more than one spot. So in practice, what this looks like is no matter where I put a vertical line on here, it always crosses it once. And nowhere can I draw a vertical line to cross this more than once. So 2, 3, 4 times. That means this is a function. Let's look here. We're going to use the vertical line test again, because this is a graph. Is there anywhere on this graph that I could draw a line that it crosses in more than one spot? Absolutely. There's a few spots, right? This whole range from -7 to -5, it crosses in 2 to 3 spots on the relation. So because it crosses in more than one spot, this is not a function. And why is because it does not pass the vertical line test. Or we could abbreviate VLT. So let's summarize and just review a minute. Our objective was, I can determine if a relation is a function. We should be able to say yes by 1, analyzing the domain and range, or input and output values, and or using the vertical line test if we're given a graph. So that's it for today's lesson. Remember, you can go back and rewatch this at any time if you still have questions or you just need a quick review.